Good day, everyone. I am John Macmac M. Abando, and I am going to discuss my topic about the subsurface condition, pressure, and temperature. Let us begin with the crude oil formation. The formation of crude oil comes from the remains of animals and plants that are buried at a depth where sediment layer is built up. It is also where pressure and temperature comes in, decomposing the remains that compressed it in order to become a layer. The depth of the layer on top of the buried, partially decomposed layer reaches thousands of meters, and the immense pressure exerted and the heat results the formation of the crude oil. As we can see on the figure, the layers of sediments is also considered as a vital part of decomposing the remains. Without the layers, the pressure and temperature required for decomposing the remains will not happen. As I said a while ago, pressure and temperature is the most critical part of the formation of the crude oil. Hydrocarbon pyrolysis, it is a thermal decomposition of materials at elevated temperatures in an inert atmosphere. It also involves a change in chemical composition. Now, let us focus on the subsurface condition under temperature, starting with the oil window. Oil window is defined as a special environment wherein it is the range of depths between 2,000 meter and 5,500 meter. It is considered as the most favorable temperature where the oil forms. Only natural gas can be found below this window. At the depth of 2,500 meter to 5,000 meter, it is regarded as the most or the favorable temperature that ranges from 75 degrees Celsius to 150 degrees Celsius in order to form oil. The organic material in source rock is transformed into oil at a temperature between 75 degrees Celsius and 150 degrees Celsius. Deeper into the ground, the temperature is higher than 150 degrees Celsius. At these temperatures, the oil is irreversibly converted into natural gas and graphite. The peak of the production of liquid hydrocarbons is between the 3,800 meter to 5,000 meter. There are no hydrocarbons below a depth of 8 to 10 kilometer. Because of the intense temperature, hydrocarbons are broken down at that range. Moving on to the pressure or the subsurface condition under pressure, as it sinks below the ground, the source rock is subjected to high pressure and then crushed by the weight of the accumulating sediments. The pressure increases by 25 bar in every 100 meters. Based on the figure shows and the statement a while ago that 100 meter is equivalent to 25 bar. We can assume that at a depth of 2,500 meter, we expect to have 675 bar or 67,500 kilopascal in order to form an oil. In conclusion, there are two important processes in the formation of petroleum. It is the diagenesis and the catagenesis. Diagenesis is a process of compaction under mild conditions of temperature and pressure. When an organic aquatic sediments are very saturated with water and rich in minerals. Through chemical reaction, compaction, and microbial action, during the boreal, water is forced out and proteins and carbohydrates break down to form new structures that comprise a waxy material known as kerogen, while the catagenesis turns kerogen into petroleum and natural gas. As temperatures and pressure increases, the process of catagenesis begins, which is the thermal degradation of kerogen to form hydrocarbon. Petroleum formation requires a specific window of conditions: too hot, and the product will favor natural gas or small hydrocarbons, but too cold, and the plankton will remain trapped as kerogen. If the source rock is buried between 2 and 5 kilometers, its temperature increases due to its location in the Earth's interior. This increasing pressure and temperature of the shale transforms it into a waxy material known as kerogen. Other important conditions for oil generation are pressure and temperature. Chemical reactions run faster at higher temperatures; at lower temperatures or smaller depths, the oil may take millions of years to form. So that concludes my presentation. Thank you and good day.